Hi, this is Cheryl Abrigo with USF Tech Transfer Office, and we're here for another tech tour in the office of Dr. Ashwin Parthasarathy, who is Associate Professor in the Department of Electrical Engineering. Welcome.
Well,
Thank you for being with us.
Thank you for having me.
I'd like to acknowledge first your 2024 USF Excellence in Innovation Award. Wonderful. And then you also won first place in 2021 Decade Prize for Innovation.
That's right. Yeah. Thank you
Awesome.
very much.
We
Yeah.
love that. We love
Thanks.
that. So your area of focus is biophotonics.
hmm
I'm going to mess that up.
Yes,
Diffuse optics and biomedical optics in neuroscience. And you have 7 disclosures with us now. 3 of them are licensed.
that's right. Yeah.
Can you tell us about the technologies, if they all interrelate with each other, if they can be standalone?
Yes. So most of my work in biophotonics is using light to interrogate tissues. And so our goal is to use different types of light and different kind of like modulations of light and different tricks with the light. So we use the light to shine light on the tissue, and then look at the diffuse light that gets reflected back from tissue.
Mm-hmm.
Now, as the light passes through the tissue, it picks up information about what's happening underneath the tissue. And so, if we analyze the data that we get back using, in some straightforward manners, but then also using some tricks, then we can get different properties about the tissue, like what's the oxygenation in the tissue, what's the oxygen saturation, for example. And the one that I'm most interested in is what's the blood flow in the tissue, or the blood perfusion in the tissue. And so this is less so to do with, kind of less of a flow in a pipe kind of situation than kind of what's the volumetric flow in the tissue that's being illuminated. So that gives you perfusion, which is a little bit different than what you would see from, let's say, laser Doppler imaging or Doppler ultrasound.
Okay.
And perfusion has a lot of extra information in some ways because it's giving you information about the microvasculature, and then that can give you and that microvasculature information will allow, we hope, will allow you to help diagnose diseases, understand brain function, understand tissue function, and things like that. Yeah.
Very interesting. What triggered your interest in researching this area?
So I've always been, I guess, interested in measurements.
Okay.
I guess since I was thinking about this a little while ago, and I think I like to make different types of measurements and play tricks with it. And then when I went to grad school at the University of Texas at Austin, I started working with light. And I found that was fascinating, the way in which light can, and there are certain unique ways in which light is very challenging to use. For example, light bounces around in tissue, which is obviously why we can't see through us, right? So that makes detection a challenging problem. But because light bounces around so much, it interacts with so much of the tissue that you can learn more from it. So, so there is this nice interplay between the challenge of the problem and also the amount of information you can get from it. And so through my studies, I got interested more into it, and I found this was really interesting. And I'm always interested in how the brain works and all that. So I think that's always been like a cool area for us to play with.
That's very interesting. So the technologies you have that are currently available, are you more looking for someone, is it at a point where you need more sponsored research, or are you looking to have someone come in and license it and get it right out to market?
So we have a little bit of both.
Okay.
So I think you mentioned six,
Seven.
seven, right?
Mhm.
I think we just submitted one more. So
Okay. All right.
So there are different types of technologies. Some of which are more really oriented towards making like the measurement a little bit better.
Okay.
But some which actually are that allow you to solve some critical problems with how these technologies are applied. I think one of the things is that we're doing is that we have one technology where it allows you to go deeper and measure deeper tissues into the brain. So that means that with a surface-based measurements, you're sensitive to more brain tissue. I actually have a startup company that has licensed some of these techniques. So we're really pushing to see if we can get a small wearable type device into the market, and that I feel is incredibly rewarding to me because, well, because building the technologies in the lab is great, and I love the science of it.
Hmm.
But I really wanted to go. I really wanted to be adaptable, and so people can use it.
Right.
And I think I think that aspect of it, and that aspect of it, and the clinical translation of it
Hmm.
also is like incredibly rewarding.
That's very
Yeah,
important.
yeah.
Yeah. Well, great. This has been very insightful. I love it. We're all nerds, so I love learning this stuff.
Thank,
Thank you for joining us today.
thank you so much.
Thank you. We'll see you next time on our tech tour.